In this screencast, we are going to go over the zero exponent property. So you will see, on your note packet that we have when the base is raised to the zero power, we get the number 1. And we're going to talk about where this is coming from. So let's say we take x to the third divided by x to the third. So if we think about what we did the other day when we were dividing the bases, we subtract the exponents. So this would give us x to the 0 power. 3 minus 3 is 0. If we also think about when we divided how we wrote out x to the third, which is xxx, over x to the third, which is xxx, we could simplify, and everything would simplify to the number 1. So because these are saying the same thing, this is why, or proves, that anything to the 0 power will equal 1. So basically what's happening is for something to be the 0 power, the bases have to be the same and the exponents are both going to be the same. So anything to the 0 power is 1. And what I like to do is I like to kind of like underline so I know what I'm looking at. So for example, 5 to the 0 power, that whole thing is to the 0 power. This is going to be the number 1. Letter B, x to the 0 power. Okay, that whole thing's to the 0 power. That's going to be 1. And notice now it's not x to the first power. It's just 1. Letter C, the whole thing in the parentheses is raised to the 0 power. Again, going to be just 1. Now, letter D, we have 5, and then we have a to the 0 power. So this 5 is going to come down like normal, and then this a to the 0 power, we'll now multiply by 1, so this answer will be 5. Sometimes when I write it this way, I just cross out the a to the 0 power because I know that's going to be a 1. All right, and then letter E, our numerator, the whole thing is raised to the 0 power, so the numerator is 1, but then that y is going to come down and stay in the denominator, so we'll have 1 over y. Letter F, we have negative 3a squared to the 0 power, which will give us 1, and then we still have 6a to the third multiplied by 1, which is 6a to the third. Again, you can just like draw a slash through those. Anything with a 0 power is going to be the number 1. Now, it just depends on what's going on with it. So anything to the 0 power is going to be 1. And then you're going to take a look at the trisum problems. So if you want to pause and give them a try, that's fine. But we're going to go over the answers. So number 1 should be 1. Number 2 is going to be 1. Number 3, so this piece will become a 1, but you still have your 4x squared. Number 4, the numerator becomes 1, denominator becomes 1, 1 over 1 is 1. Number 5, this whole parentheses is raised to the 0 power, so that's 1, but we still have the 4 out front, so our answer will be 4. And then number 6, b to the 0 is gone, so we have 3a to the third, c to the negative 2 power. And we're going to talk about negative exponents here in a second. So anything to the 0 power is always going to be 1. So the last part of the exponent notes is about the negative exponent property. And what that is saying is that if you have a base raised to a negative exponent, so here it's negative m, what we're going to do is we are going to basically make it a fraction, if it's not 1 already, by putting it over 1, and we are going to flip the fraction. So notice how the 1 is now on the top, and a to the m, now positive m exponent, is on the bottom, denominator. Same thing happens if our exponent is negative in the denominator. We're going to flip it, and that's going to go in the numerator. So you could look at it like this. So looking at letter A, and again, I'm going to kind of group things together. So x to the negative 4th power, I can't let that as a negative exponent. So I'm going to make it a fraction by putting it over 1. And now I'm going to flip the fraction. 1's on top, x is on the bottom, now raised to the 4th power. So these are saying the same thing. Letter B, again, I have a number to a negative exponent, so I'm going to flip it. 1's going to be on top. Now 3 to the third power will be in the denominator, and I can go one step further and take 3 to the third, which would be 1 over 27. Letter C now gets a little tricky. So we still have our 5, but this a to the negative 2 power, that is going to have to get moved. So we're not going to flip the entire thing. So this is where we have to be paying attention. So in problem A and B, you could flip the entire thing because everything in the numerator was raised to a negative exponent. But in letter C, only the a to the negative 2. So the 5 is going to stay put. I'm going to draw my fraction line, and then my a to the second power is going to go down in the denominator. So if it does not have a negative exponent, it stays put, does not move. So letter D, we have a 2 over k to the negative third power. Well, 2 is going to stay where it is. This k to the negative third power, we're going to put it up with the numerator. And you could put it over 1, or you could just say 2 over, or oh my gosh, sorry, 2k to the third. All right, letter E, again, if we look at what has a negative exponent, that must get moved. So that a to the fourth is going to stay where it is, but b to the fifth is now going to go in the denominator. Same thing with letter F. I'm only looking at what has a negative exponent. So that 6 is going to stay where it is. D to the fourth will come down into the denominator, and now I'll have a 1 up in the numerator. And then letter G, this whole thing is raised to the negative 2 power, so I can take the whole thing and flip it. And then I'm going to go one step further and apply that squared. So I'll do 4 squared, which is 16, and then x squared. So make this a little smaller. So I'll have 1 over 16x squared. And then the last problem, we are looking at negative exponents, not negative numbers. So that 3, that negative 3, that's going to stay put. We're not going to move that. The only thing we're going to move is that x, and it's going to come in the denominator and now become a positive 2. So we're only moving what has a negative exponent. So when we have a negative exponent, we are going to flip to the other side of the fraction. Okay, so if you want to pause and give these a try, you can do that. We're going to go over these answers just so we all have the right thing. So for number 1, my gosh. For number 1, the whole thing is raised to a negative exponent. So I'm going to put it over 1 and I'm going to flip it, and I get 1 over 6 to the third power. And then I can go one step further, and I'm going to take 6 to the third power, which is 1 over 216. Number 2, only what has a negative exponent is going to move. So my 4 is going to stay in the numerator. X now goes in the denominator, raised to the 6th power. Number 3, this one I'm trying to trick you. There is no negative exponent. So we will take negative 3 to the third power, which will give us negative 27. So negative 3 times negative 3 times negative 3. Only negative exponents get moved. So in number 4, my b is going to stay put, but my a to the third is going to move down to the denominator. Number 5, same thing. My 2 is going to stay where it is, but n squared now goes to the denominator. Only moving what has a negative. In number 6 now, I'm going to take that b and bring it up to the top, to the numerator, and I can just let it like this. So you could put it over 1, but that is kind of the same thing as 5b to the first power, or just 5b. Number 7, we have 2 things that have negative exponents. So the 3 is going to stay where it is. The f is going to come on top, f squared, and now g to the third will get put down in the denominator. So only moving what has a negative exponent. Number 8, only have b to the negative 8th power. That's the negative exponent. That negative 2 does not have a negative exponent. So that's going to stay put, and we'll bring the b to the 8th up to the top. And then, yep, for the last one, we have 2 pieces that have negative exponents. So we'll have 4a to the 3rd stay where it is. B squared now goes in the denominator, and so does c, or you could just say c to the 1 power. So we are only moving what has a negative exponent. So if you look at all of the examples I did, I circled that piece. That piece has to move. Everything else will stay exactly the same.